In July 2025, astronomers, working with the Atlas Survey telescope in Chile, detected a faint moving object that didn't belong to our solar system. The object, now known as 3I Atlas, became only the third confirmed interstellar visitor after Oumuamua and 2I Borisov. Its hyperbolic orbit clearly showed that it was just passing through a traveler from another star system, making a brief stop in ours. Follow-up observations began almost immediately from observatories around the world. Images from space-based telescopes revealed a compact nucleus wrapped in a hazy coma of dust and gas. The nucleus was estimated to be a few kilometers across, smaller than many comets found in our solar system, but unusually active for its distance from the Sun. Scientists were surprised by how early 3I Atlas began releasing gas. Even when it was far from the Sun, it showed strong outgassing of carbon dioxide and traces of water vapor. This suggested that the comet's surface composition or structure was unlike any typical solar system comet. The gas-to-water ratio was found to be much higher than expected, meaning it may have formed in a colder, carbon-rich region of its home star system. Infrared instruments detected an extended cloud of gas and dust around the comet, several 100,000 kilometers wide. The pattern of emissions showed that the object was highly volatile and that solar radiation was driving large amounts of gas into space. Ground-based telescopes later captured a long, faint tail stretching behind it, confirming that 3I Atlas was becoming more active as it neared the Sun. Polarization measurements in September added more mystery. The light scattered from the comet's coma showed an unusually strong negative polarization, which indicates the presence of fine dust particles or unusual grain structures. This is rare even among the most well-studied comets, suggesting that interstellar comets may carry materials not commonly found in our solar system. According to orbital projections, 3I Atlas will reach its closest point to the Sun, about 1.4 astronomical units, in late October 2025. It will not come close to Earth, staying nearly twice as far from us as the Sun is. During its perihelion, the comet will pass behind the Sun from Earth's perspective, making it temporarily invisible to ground-based telescopes. While these astronomical observations continued, the United States experienced a partial government shutdown in early October 2025 due to a lapse in federal funding. NASA, like other federal agencies, reduced many of its operations and furloughed most of its employees. Only essential missions, those needed to protect spacecraft, data, and astronauts, continued as normal. This meant that some public updates, data releases, and outreach activities slowed down temporarily. Despite this, global collaboration kept the research active. Space agencies in Europe, Asia, and other regions maintained continuous observations. Instruments on Mars orbiters, ground telescopes, and space-based observatories together continued tracking 3I Atlas, ensuring that data collection was not disrupted by the U.S. shutdown. As with previous interstellar visitors, theories about the comet's origin range from scientific to speculative. Some researchers proposed unusual explanations for its chemical behavior, but the consensus remains that 3I Atlas is a natural comet, a frozen fragment from another planetary system. Its extreme composition and behavior, however, challenge scientists to rethink what interstellar objects can be made of and how they evolve over time. After passing behind the Sun in late October, 3I Atlas is expected to reappear in the night sky around December 2025. By then, it will be moving away from the inner solar system, gradually fading as it heads back into deep space. Although it will eventually disappear from our view, the data gathered this year will continue to offer valuable insights into how planetary systems form and how material moves between stars. In short, 3I Atlas is not just another comet. It is a messenger from beyond, carrying chemical fingerprints of a distant world. Its discovery reminds scientists that even in times of uncertainty on Earth, the cosmos keeps sending us clues, and it's up to us to keep listening.